Hi, and welcome in the Attacks Against the Client section. As the title says, this section we are going to discover attacks which specifically target the client, so the browser and the user. This means that these attacks will execute in the user's browser, although the malicious data is gonna pass through the web server, but it doesn't really gonna affect the server side. But these are still pretty serious attacks. The worst case scenario is usually that an attacker can take over user's account, and if that user is an administrator, then he will basically have full access to the application. Of course, after that, the attacker can still try to go further and attack the server side, but we will see that in the next section. This lecture is about the reflected cross-site scripting attack. The cross-site scripting is a kind of vulnerability where an attacker can manipulate the application in the browser. So, in theory, if you have a form, for instance, to get your name, and you submit this form, then the application is gonna use your data to create something in the HTML. For instance, generate a page where it writes your name. So if I put my name here in, Gary, then the application will generate an HTML code where it puts my name here, Gary. However, if you here submit some kind of HTML code, then when the website generates this page, then it will include the HTML, and this is what's going to be returned to the browser, and the browser will not be able to distinguish the original HTML content from the submitted input, so it will just render the whole thing as HTML code. This way, it's possible to alter the web page with an input parameter. We call a cross-site scripting reflected if the malicious input is not stored on the server, but rather reflected back to the user in the resulting page. So a request is sent to the server with the malicious input, and the malicious HTML code is then immediately delivered back to the user. In this case, the data is not going to store it on the server, but it's still going to take an effect on the user's browser. Of course, you see, the user has to submit the malicious data, so the attacker has to find some way to trick the user to submit malicious data. So usually, the reflected cross-site scripting involves some kind of social engineering, like sending malicious link to the user, and when the user opens this link, then the attack will execute. Or sending the user to a specific website, and when he opens it, then he gets redirected, and through that redirect, the malicious input will be submitted. Things like that. So there's always some kind of social engineering aspect. So let's see this in practice. As I told you earlier, the Who is Your Daddy application, what we wrote, is vulnerable to reflected cross-site scripting. So we can just go to var www.html and open our whoisyourdaddy.php. So if you look at here in the PHP code, you can see that we are taking the name parameter directly from the request and using it to include it in the HTML page. So we don't care what's exactly in this name parameter, we'll just turn it to uppercase and then put it in the page. That's pretty dangerous because if we go to the page on localhost, there it is, whoisyourdaddy.php. Then you remember when we say Gary, then it's going to be just like I'm your father, Gary. But what happens if I say I, Gary, I? You can stop a little bit if you want to think about it. Just try to figure it out what happens if we submit this request. Okay, let's try. So the I stands for italic. So if I submit it, then you could see that the string Gary became italic because the PHP code turned our input string to uppercase and then returned it, but it's still HTML. Let's look at the HTML code. When I'm opening the source code, I do Control U. Here you can see that this is our submitted string. You can see that everything is uppercase, but it's still HTML. The thing is that HTML is case insensitive, so it doesn't matter whether it's uppercase or lowercase. If it looks like HTML, the browser is going to render it. So let's try the most typical cross-site scripting attack. Script tag, and then JavaScript alert to pop up an alert window, and then closing the script tag. So let's see what happens in this case. What we are expecting is a pop-up window with the number 42 in it. But nothing happens. So let's look at the HTML code again. And you could see that the text is here, but it seems like it was ignored by the browser. We can turn on the developer tools. Specifically the console. And you could see that in the console there is an error that alert is not defined. So the problem is that when the PHP code turned our string to uppercase, it broke the JavaScript inside because JavaScript is case sensitive. So alert with uppercase is not the same function as the lowercase, and most importantly, it doesn't exist. So this happens many times that you kind of feel that there is a vulnerability there, but when you try to exploit it, it doesn't work. In that case, never give up, just try harder and try to figure out a workaround. That's what we're going to do. So as you might know, JavaScript can be downloaded from other URLs as well. So it doesn't have to be embedded in the page. There's a source parameter for the script tag where you can define the URL where the JavaScript should be downloaded. And when the browser downloads the JavaScript code, it will be executed as if it was inside the script tag. The source attribute is not even subject to the same origin policy, so you can even host your JavaScript on other servers on the internet. So for our attack to work, we need to have our JavaScript somewhere. In our test, we'll just have it on the same server, but it could be somewhere else as well. So I will create a file called attack.js. And I deliberately wrote it with uppercase letters because that's going to be important for the attack. And I will just put some JavaScript code in it. Alert, I am the king of the universe. So this is basically pure JavaScript code, and it hosted on our server as attack.js. So what we can do in the browser, I close this, and instead of writing the script code inside the script tag, we can write script and not closing it, but saying source is HTTP localhost slash attack.js, and then we are closing the script. So again, it's script source src, sorry, HTTP and localhost attack.js. So as I said, it's now localhost, but it could be anywhere else on the internet, which can be reached from this page. Let's submit. And yes, the attack worked. It's awesome. The JavaScript in the attack.js was executed. That's why we get this pop-up window. So let's say OK, and let's look at the HTML source. As you could see here, here is our script tag transformed to uppercase letters. So the thing is that HTML is case insensitive, and also domain names are case insensitive. So as long as the attack.js is uppercase on the server, then it's going to be a valid URL. So when the page is loaded, the script tag is executed, the JavaScript code is downloaded from this page and executed as well. This is a really good example that if your attack doesn't work on the first try, just keep trying. You're going to fail many times, but the point is to keep your goal in mind. So let's talk about protection. How you could protect against cross-site scripting. The protection is two-sided. First is about validation, so validating all the input which comes to your application, and the other part is output escaping. So when we talk about validation, the point is to always make sure that the data which you're receiving is the data what you're expecting. So if it's a name, then you shouldn't allow any characters or anything. You just allow characters which are normally in a name. So letters, it shouldn't be longer than 50 characters because most of the names aren't, etc. If it's about a telephone number, then it's supposed to only have like digits and maybe a plus sign, and also limited length. So when you receive input in your application, then before doing any processing, you need to make sure that the received input fits to the data what you're expecting, and if it doesn't, then you should throw it away. Validation should be done with any kind of input what your application receives. Validation, however, is not enough. The other side is output escaping. So the problem here was that the browser, when he receives this data, it is not able to distinguish whether this is a text or HTML. Of course, in web applications, it's reasonable that some texts need to use special characters like the less than symbol. So you have to find a way to allow this. The way is to use encoding. So you can use HTML encoding to encode this string when you're building this page. And this way the browser will see that that's not really HTML because it's encoded. So it's supposed to be only printed as a text. So you've probably seen HTML encoding at some point. For instance, the less than is like ampersand LT as less than and semicolon. And greater than is GT semicolon. So some characters have a short form like the less than and the greater than, but most of the characters are just ampersand and then number and semicolon. So you can go to burp to the decoder and say, for instance, test encode as HTML. And you can see here that T is encoded to this string, E is to this, etc. This means here that it's in hexadecimal. You can also write it in decimal, then you don't need the hash and the X, just the number. What you need to do in your application, make sure that all the data which was user input at some point, when it used to generate HTML, it's getting HTML encoded so that the browser knows that it's simply data and not HTML code. Of course, most of the web frameworks have some kind of built-in mechanism for that. It shouldn't be really difficult. Usually the difficulty and the reason why there are still cross-site scriptings everywhere is that people are not encoding all the data because they don't think that this data came from the user at some point or the user has some influence on it. They just think it's some data from the database, and they forget to encode the data when they generate the view. If we go back to our PHP application, we can fix this with a PHP function called HTML special cars, HTML special cars, and then we put the data in it. So the HTML special cars will transform all special characters to the HTML encoded version. So if we go back to the browser and reload this page, you can see here, this is where we submitted the script tag with the URL. And as you could see, now it appears as normal text and we don't get the pop-up window. Actually, when you see it, that already means that it wasn't executed as HTML, so that's a good sign. Control U, let's look at the source. And as I told you, the special characters, so the less than and greater than signs, were changed to the HTML encoded version. This way the browser knows exactly that this part is HTML, this is just a simple text, and the rest is also HTML. As an exercise, you can do two things. First off, implement input validation in this application. So try to think about how a name should be validated, what characters should be allowed and what doesn't. And in PHP here, before you do this line where you echo the result, you should transform before this line. You should check whether the name which was submitted is really a name or it's something else. If it's something else, then you can just drop it. That's the first exercise. And the second is that this HTML special cars function has its own flows. So it might be possible to work around it and find another way to do cross-site scripting even if this protection is in place. I can tell you right now that I don't know the answer to this question or to this exercise. So if you find a way to circumvent the HTML special cars function and still do a cross-site scripting, then you can post it here under this video. Otherwise, I will see you in the next lecture where we are going to talk about the stored cross-site scripting. Bye.